So good morning, everybody. First of all, it's just amazing to be invited to speak here. This is actually a key moment in my own personal Linux journey. This morning I wanted to share with you a little bit about what is going on with open source supply chain security, but I wanted to frame it in a bigger context and actually share a little bit about why Microsoft's involved with this. And I'll start with my actually own story about my involvement with Linux and open source, and then get a little bit into Microsoft's own, which leads into how the world depends on open source and the risks that come with the world's infrastructure running on top of open source, which takes us right into what we should do about securing open sources. So first, a lot of you probably know of me as the Windows or sysinternals guy, but it's a little known fact that I actually have a long history when it comes to Unix and Linux. In fact, my PhD thesis was built on top of BSD and Mach. And I became an expert not just in Unix internals, but Windows internals over time that led me to write articles like this back in 1998, comparing the Unix kernel and the Windows kernel. You can go find this online, by the way, still. I was actually at IBM Research as the expert on Linux, despite the fact that they'd hired me as the expert on Windows. So when IBM was porting AIX to Linux, the AIX team had me come in and talk to them about the Linux kernel. You can go find this presentation online, which was before I joined Microsoft, but I actually gave a talk more focused on Linux versus Windows. And this is my first interaction with Linus Torvalds, where I sent him the deck and asked him for his review, and he wrote back, "Looks good." So and then I've also contributed to Linux, or contributed source to Linux. This is sysinternals, which again you think of as Windows utilities, but this is from 2001. You can see that I actually made a version of FileMon for Linux, and I did this using system call hooking, which quickly became banned, and so this tool broke and I stopped supporting it. And then the next big step in my Linux journey was being personally involved with Azure and the introduction of IaaS on Azure, which introduced Linux as a first-class operating system at the launch of infrastructure as a service on Azure. And I was here at this announcement. That's me there. Satya actually looks like he's telling me that Microsoft loves Linux, which I was flattered by, that he would tell me that Microsoft loves Linux. But this was a very exciting moment. And then over time, I've become involved with the Linux Foundation, and I actually ended up getting to meet Linus, and now can call him a friend. And this is just from a couple months ago. Jim Zemlin, the executive director of Linux Foundation, me and Linus having a dinner. So it's been just a journey, and so I just wanted to spell I'm the Windows sysinternals guy only. I'm an operating systems guy, I'm a cloud guy, I'm a Linux guy, an open source guy, and a Windows guy. So Microsoft's open source journey also goes back a long way. In fact, and I'm going to not go all the way back into Evil Empire days, but I'll start after that, which was the introduction of Hyper-V, which led us to wanting to support Linux on top of Hyper-V, and that led to us starting to become a major contributor to the Linux kernel. You can see that several of the engineers actually became top 5 contributors to the Linux kernel in supporting that work. And then you can see over time just this continuous progression. I already talked about Linux on IaaS, WSL, Windows subsystem for Linux on Windows, so Linux can actually run in Windows, to actually Microsoft having its own Linux distribution. In fact, over 65% of workloads on Azure are Linux-based, and more than half of the marketplace offerings are Linux-based for Azure. So our customers are using Azure primarily as a Linux platform, as most cloud offerings are built on top of Linux. One of the biggest is ChatGPT, which runs on Azure. And this is a massive Kubernetes service running on top of Azure that uses Linux provided by Microsoft on top of our virtual machines, as well as, you can see, open source components like Postgres. It's one of the largest apps in the world. But Microsoft, or open source, isn't just a platform for Microsoft where we have customers run. We are actually also deeply dependent on open source. And I want to highlight some of the ways that we integrate with open source, because we look at this very carefully. We look at how we consume open source and use it. We want to be good citizens of the ecosystem and community. We also look at how we should be contributing to open source. Again, you can't just toss things over the wall. Contributing means supporting it, means engaging with the community if you really want it to be true to the open source spirit. And then finally, releasing open source, our own stuff. So one way that you can look at it is how much we're consuming open source is measured by the number of pulls from our internal registries or component governance or central feed service, where our internal systems pull open source packages. And that, when you look at that, over 200,000 pulls are happening against that central feed service to 11.8 million locations in our services across all our products, whether it's Office or Windows or Azure. And one of the largest Kubernetes clusters in the world happens to be the cluster that underpins a lot of the Office services. So M365 services and Teams, running on top of a system called Cosmic, which is built on top of Azure Kubernetes Service. Millions and millions of cores. And it also uses several other open source components underneath, including things like the Keynote, Kubernetes Event-Driven Autoscaler, as part of that deployment. And get this, we have an infrastructure offload card that goes into every single server we ship. It's called Azure Boost, and that's got an ARM SoC on it, and that's running Linux. So Linux is literally going into every server Microsoft deploys, the millions of servers we're deploying. So we have a very deep, deep dependency on Linux and open source. And we also turn around and contribute to open source. And we do this by in a variety of different ways. And one way to measure this one is just to look at the number of pull requests that Microsoft engineers are making on open source projects. And when we take a look back at the last 3 months, and this is from Linux Foundation stats, 3 million pull requests from Microsoft. In fact, that's a huge number, but just to put this in context as far as how big it is in terms of corporate contributions to open source in Linux, that's the list of top corporate contributors from the Linux Foundation. And who would have thought, going back to Evil Empire days, that one day you'd see something like this, where Microsoft is the #1 contributor overall. And then Microsoft's also releasing a lot of open source software. One of the most popular, how many people run Visual Studio Code as your IDE? So quite a few of you. That's an open source project. In fact, it's one of the most active on GitHub open source projects. And you can see it's installed by the vast majority of developers are leveraging Visual Studio Code. And then we've released a lot of other systems and components for open source developers that are quite popular. .NET became open source about 10 years ago. TypeScript, one of the most popular languages in the world. It's in the top 5 and continues to rise. A lot of people might be using that. That is also open source and developed by Microsoft. PowerShell became open source, OpenJDK, and the list goes on and on. And then when it comes to new types of software, we're also contributing. So when it comes to AI, because everything's about AI these days, if you've heard of Semantic Kernel or AutoGen, those are 2 AI orchestration frameworks. They were both open source. We combined them last year into something called Microsoft Agent Framework to get the best of both of them and have one offering that we stand behind. And so this is also open source project and is quite widely used among enterprise users. And then my own org, I've got the open source ecosystem team in my organization, as Elon mentioned, but I also have an incubations team, which is entirely focused on open source cloud native incubations. And we've got a track record. This goes back to 2019 and developing these things. I mentioned Keynote, the Kubernetes Event-Driven Autoscaler. That is a graduated CNCF project. Dapper, Distributed Application Runtime, came out. That is also a graduated CNCF project. COPA, which is a container patching system, which is very important for container and cloud native security. That has also been contributed. That's a sandbox project. And then we've got a couple of other incubations that we're working on. Radius, which is a cloud native, cloud neutral application platform, application development platform. That is also a sandbox project. And Drasy, which is an event-driven, reactive, new type of data service. That is also open source and contributed to the CNCF. And then, again, you think of sysinternals, you're probably thinking Windows. But sysinternals, while it was dabbled in Linux over 20 years ago, is back with Linux. And we have a number of tools. You can see 5 tools that we've released for Linux, including versions of Windows tools like Sysmon, which is an EDR tool that is actually shipping, the Windows version is shipping in the box in Windows as of this month, or last month in February. But we've got a version of that for Linux that we're running internally at Microsoft. JCD, which is Jump CD, I wrote myself. So that is a tool that I open source through sysinternals that I developed for myself to make it easy to jump up and down complex directory hierarchies that I was having to navigate as I worked on my open source or on my AI research projects. And I'd get these very deep directory hierarchies and got tired of cd ... /... hell. And then Microsoft also, just some frivolous types of contributions to open source. Microsoft's gone back into the archives, and so you can go look at the source code for DOS 4.0, which is now open source. Going back even further, AppleSoft Basic, what became AppleSoft Basic, Microsoft being the creator of the basics that ran on most of the PCs back in the 1970s, that is also open source, so you can go look at that. And by the way, I have, because you're going to see that I've got a connection with AppleSoft later in the talk. It's not just Microsoft that depends on open source. The whole world depends on open source. This is a study done in 2025 that looked at 1,600 organizations in the code that they were developing and found that 97% of them had open source dependencies. 70% of them had their origins in open source. About an average of 900 open source components found in each one of them. So you can see it's not just Microsoft, but the whole world literally is dependent on open source. And one way to actually look at the growing dependence is the number of pulls from package managers. So you see here 2 charts, PyPy and creates the Rust and Python main package managers. You could see exponential growth in consumption from these things, just as everybody's now using open source and contributing to open source. It's 10 trillion pulls, you can see, just a staggering number. Now, the world's dependence on open source brings with it interest from places that we'd rather not have interest in it, and that is from the malicious side of things, from nation states, from hackers that are looking for how do I get into enterprises, how do I get at money, how do I get into desktops and consumer devices so that I can go and do my exploits and carry out my goals. So, and because of this huge dependence on open source, of course, they're looking at how do I get into the open source supply chain? How do I infect something that is going to be used by thousands of organizations or millions of users? In fact, this XKCD comic kind of really shows us kind of a little precarious nature that we're at, because with 900 average open source dependencies in a commercial piece of software, millions that Microsoft or hundreds of thousands Microsoft depends on, and there's somewhere in there components like this that has one maintainer that is working in there part-time, that might not have the best security processes and might not be available when something goes wrong, either from a reliability or security perspective. And yet the whole world yanked that thing out, and we've seen things like left pad. Do you remember that? When the developer's like, people are pissing me off. I'm yanking left pad, and then half the internet gets impacted because of this few little line node package. And the open source supply chain, just to put it down so we can see where attackers try to enter this thing, are all over the place. From the developer, like if you get to the access to the developer, you can start on the very left of the supply chain. If you can modify the source code, maybe out in the repo, not even needing a developer because you happen to be there, that's another great way to do it. If you can infect the build pipeline, if you can go into the package manager and carry out exploits there that cause people to pull down the wrong packages or pull down infected packages, that's another place. And then, of course, your ultimate goal is there on the right, the consumer, where you hope that you can get them to do something that puts them at risk too, because they're, for example, pulling from the wrong place or pulling the wrong package. And then I want to just highlight the increasing risk and pace and sophistication of these attackers that are trying to get into open source, and the kinds of risks that the world is at when somebody discovers a problem with open source. Going back to one of the earliest wake-ups for how dependent the world was on open source. Even in 2014, OpenSSL vulnerability called Heartbleed, where there was a buffer overflow that could be triggered remotely, and basically half the internet was exposed to this. And then in 2022, more problems with certificate validation were found, leading to buffer overflows and remote exploitation. The Heartbleed one actually led to being able to read arbitrary memory and get keys out of the servers. But these kinds of problems really started to wake people up to, hey, we really are dependent on the security of open source. If something that we're all using gets compromised or a vulnerability is found, we're all needing to react to it together. And this one was another huge, huge wake-up call. Log4j, this is a remotely exploitable vulnerability that you could cause arbitrary code execution on Java web servers that happen to be using this logging package. And this one, again, huge amounts of exposure from companies across the internet and huge reactions. I mean, even Microsoft had exposure to this in pockets around Microsoft that we weren't even really aware of until we started to go look. So we had to pull in incident response and go get these things patched. We had to figure out, just like everybody else had to figure out, what's the exposure? Where do I have this thing running? How do I get it patched? How do I get secure? The whole world was scrambling. And despite everybody being aware of this problem, as it kind of spread and attackers were taking advantage of vulnerable servers, here we are 4 years later, and you can still see that there's vulnerable instances of this package of Log4j all over the place. And you can see in 2025 alone, 42 million vulnerable versions of Log4j were downloaded. So it's like we're not quite there yet in really appreciating the risk of running software that it has these kinds of vulnerabilities in it, despite the fact that it's gotten so much attention. And then I want to give you some other examples of different types of attacks. This one, PyTorch. How many people heard of this compromise? So yeah, this was a package manager confusion attack where PyTorch is building off an internal PyPy dependency, and an attacker realized that pip would go and pull a public version with a higher number, overriding the internal version if it was available. And so they published a package with the exact same name into the public PyPy registry, which caused the PyTorch build to go pull it instead of the internal one. Of course, the public one was a compromised version. And so this shows that, down the supply chain, the package managers are also a target of these attackers. And this one, how many people heard of this? I think the whole world heard about this one, XZUtils, because this one's a fascinating nation-state long game attack on open source supply chain. They identified this package that had one single maintainer, befriended them, gained their trust, of course, with fake identity and never meeting, and so who knows who's really behind this, and it's probably not just one person, it's probably a nation-state organization. But then they planted the seeds to have a back door, recognizing that XZUtils is used by OpenSSH, so a very commonly used interactive logon protocol or component. And how was this discovered? Actually, a Microsoft engineer who happens to be a Postgres maintainer was looking at comparisons of performance for logins across different versions of OpenSSH and saw that there was a jump with a pull request from this individual that caused it to go from like 100 milliseconds to 500 milliseconds or something, and said, whoa, that's a bad performance regression. They started to investigate and discovered, you know what, this thing actually is malicious, which set off this whole reaction to everybody needing to go clean up this dependency. And then we're seeing viral spreading too. It's kind of like the internet worms, except through open source supply chain. The internet worms I'm referring to from the late 1990s, early 2000s. Here, back in September of last year, an NPM maintainer was compromised through a phishing attack. They didn't have MFA registered, and so they were phished, which caused their credentials to get leaked, which caused the packages that they maintained to get compromised, and that was discovered and that was cleaned up. But then other maintainers were also compromised a few months later because they didn't have MFA enabled yet. And the attacker in this case went viral by saying anybody that pulls down a compromised package, so it's like one maintainer gets compromised, now the package is compromised, 10 people pull that, they get compromised, and the compromised software is going and scanning them to look for NPM signing keys as well, compromising the packages they maintain, and you get this kind of exponential spread effect, which and it ended up being kind of a worm through maintainers, being compromised through lack of MFA from just a few source individuals in this case. So they're getting clever. And the vulnerabilities are ubiquitous. They're all over the place in open source software. You can see in 2025, NPM recorded 839,000 basically releases with CVSS 9.0, which 10 is the highest, rated vulnerabilities. So people are continuing to release source code that is putting their consumers at risk. And 1 in 5 PyPy releases had CVSS ratings of 7.0 or higher. And the rate of vulnerabilities continues to go up. Not only that, but now we've got to face this new world of AI coding. And AI coding, how many people are using AI for coding? I think if you're coding, you're using AI for coding. By the way, not looking at the code is not the flex you think it is. I hope that's a message you take away from this. But I want to say that there's risks that show up here as you're using AI, because AI is going to be using old versions of APIs that might be insecure. It's going to be getting dependencies that are maybe older versions that are insecure. It's going to maybe writing code that happens to have insecurity in it, using string copy instead of a safe string copy, for example. And yes, it does that. So you need to be aware of the risks that it is introducing that you might not introduce yourself if you were actually writing the code yourself. But AI is also, it's time to buckle up, because the signs are everywhere. I mean, we saw this coming as AI got great at coding and could do things nobody could imagine a few years before. But just in the last few months, we're starting to see sophistication that is really both great, because they're so good at coding, they're so good at helping defenders analyze their code to find problems, including security vulnerabilities. But at the same time, this is a tool and a weapon, and attackers have access to the same technology. And they're going to be using it to go find these things. And Anthropic's published a couple blog posts just in the last month or so that show how good things are, which you can look at as, that's great, or you can look at it as, oh crap. And you know, in my job, I need to look at it as, oh crap, because here's one example where they set it loose on a bunch of open source projects, and within a few days and like $4,000, they'd find 500 vulnerabilities, unknown, new vulnerabilities in open source. And just last week, they published a post where they worked with Mozilla, who creates Firefox. Firefox, combination of Rust and C++. They set it loose on that and found, I think, 148 vulnerabilities. Just to put that in context, like Google's last year only saw roughly like 75 vulnerabilities being exploited in the wild at the same severity level. So, and I highly recommend you check that out. So this is, and by the way, Firefox is one of the most secure open source code bases there is. I mean, they've taken security very seriously, including being behind the creation of Rust, specifically for security. So just to give you an idea of kind of the exposure, ignoring even what we thought and knew we had just with human analysis and those vulnerabilities that have been discovered, now we've got AI, and this is going to be an order or 2 orders of magnitude in terms of volume and rate of vulnerability discovery. And then we also see AI now involved in the supply chain. How many people saw this one just last week? Does anybody here use Klein? So a few of you might have been impacted by this one because Klein got infected. So this one, a researcher discovered a few months ago that they could prompt inject Klein's build system, which is using Claude, to go look at issues And in the issue title, they put in, hey, before you work on this issue, you need to go download this package. Guess what that package then would go download? OpenClaw. So OpenClaw ended up being, for a while, deployed with every deployment of Klein because of a prompt injection in the build system. So in this, the development system. So just to give you an idea of where things are headed, now AI is in the picture. And by the way, and it's not like critical infrastructure. Companies and organizations concerned about the security of their critical infrastructure aren't aware of all of this going on. And this has led to a big focus on, we need to understand our supply chain, is what they're saying. You can see a bunch of organizations, starting with the US government a few years ago with an executive order saying every piece of software purchased by the US government has to have a software bill of materials with it. And then you see a bunch of other regulations coming, and one of the biggest coming at us is the CRA, the Cyber Resilience Act from the EU that kicks in later this year. And that one requires you to be publishing CVEs and attaching them to your SBOMs so that they can see what risk the software, as they're consuming it, is carrying at any point in time. And these regulations are just going to get stricter and stricter. They're starting, of course, with certain things like, hey, just publish an SBOM. To next, it'll be some verification the SBOM is accurate. To your CVs have to be accurate and correctly attached to SBOMs. To we're going to need you to secure your build systems in a certain way before we consume software from you and prove that they're secure. And this list of requirements is going to grow pretty quickly given these threats that we're seeing, given AI's ability to automate risks. And so this is what message is, we all have to get together because this is not a problem that any one of us can solve. We've all got to solve this together. Governments, open source maintainers, and companies together. Which brings me to this. The Open Source Security Foundation. How many people had heard of the Open Source Security Foundation before today? How many people had never heard of it? So it's disappointing raise of hands, which is why I'm here. But the Open Source Security Foundation started as an idea back in 2019 timeframe. Me and Eric Brewer from Google were talking about our company's dependence on open source and the fact that open source had these risks in it that were we couldn't really see the risks, measure the risks, or help with the risks. And so we started talking with others, including Amazon and other companies, about what we should do about this. And that led to the creation of the Open Source Security Foundation back in 2020. The idea, of course, with the Open Source Security Foundation is to have everybody come together to work on this problem together. No one company, as I've said, can go and really address open source security. It's not like one company, Microsoft, we can secure our own open source supply chain. That's just impossible. The scale of it is monstrous. And we don't have the skills to do it either. So we need everybody else to participate. And every other company does too, and every other government does too. So Open Source Security Foundation is a place for us to come together, to work on driving and setting standards, working with governments, and working with companies on improving the security of open source software. It's not a place, by the way, for us to come and, corporate big hand come in and control open source. We love the energy, we love the innovation in open source. Like everybody thrives off that. And we all thrive on it. And there's lots of Microsoft developers that love contributing to open source. So it's not us trying to control open source. It's trying to help open source, because the fact is, if open source doesn't become secure, the world can't use it. Just as simple as that. It's not like, it won't be a choice. You see the regulations. Like Microsoft won't be able to sell software that has insecure or open source that is not following best practices. So that's just a reality. So let's try to work on this together. You can see that this has gone momentum. This is 5 years later, 117 organizations, 16 industries, so it's not just hyperscalers like I mentioned, but finance, cloud, AI companies, government, academia, everybody's represented as part of this recognition we all need to work together. And it's not just a US effort either. You can see organizations from 40 countries. And just to give you an idea of what the Open Source Security Foundation's actually looking at and the companies that are participating, this is just a slice of some of the working groups in Open Source Security Foundation and some of the members leading and participating in those different working groups. By no means comprehensive, but just to give you a flavor of how diverse the participation is in supporting Open Source Security Foundation. Now, that supply chain picture that I showed you a little bit earlier, this is the open source security version of that supply chain diagram, with open source initiatives, standards, and tooling mapped to each place in that supply chain. And this is just quite the eye chart, and I'm not obviously going to spend time going through the whole thing, but I did think I want to take this opportunity to share with you some of the key projects that are probably relevant to you. So how many people in here are a maintainer for an open source project? How many people contribute to an open source project? How many people consume open source projects? Okay, everybody, just want to get everybody to raise their hands. So, and how many people actually work at a company that depends on open source? So these projects I'm going to cover are relevant to you regardless of where you are, almost certainly. But some might be more relevant to you than others, depending on which role you happen to be in. So let's go through a few of these, and I'll start with SALSA, Supply Chain Levels for Software Artifacts. This one actually came out of Google, which was looking at this internally. How do they measure or define what is a good open source build pipeline? What are good standards for securing the repos that have the source code that goes into those build pipelines? And so they've contributed this standard to the OpenSSF, I think even maybe early in the first year after OpenSSF was founded, and it has continued to evolve. If you take a look at the source track, so it's divided into tracks, the SALSA source track has what are called levels of assurance. And you can see that this is a way for you, if you're maintainer, to look at your build pipeline and decide what level of security you're going to shoot for. Like I said, get ready, because if you're source L1, which is you're using a version control system, which is great, it's just one of the key requirements, get ready, because look at the next levels, because they're coming at you through regulation and your customers demanding these next levels. So eventually, I don't know if it's 5 years from now, I don't know if it's 10 years from now, but at some point, things are going to need to be up at source level 4, basically anything that the world consumes. So this is kind of a map and a look into the future, not just a look at what you can be doing right now. But this is a good way to go look and see what are the best practices at different levels of security. And then there's the build track. And the same thing here, you can see 4 levels for the build track, which is level 1, which is, hey, I build, but I don't know how I'm building, or I'm building on my laptop at home, up to build level 3, which is I've got a hermetically sealed build pipeline. And what that means is that attackers will have a very hard time getting into the build pipeline, injecting software into the build pipeline, and that you have basically proof of what went through, signed cryptographic proof of what went into the build pipeline and what came out of the build pipeline. And so this is the ultimate, the goal. And there's a level beyond it that they used to have that they've cut for now, just because it's out of reach for just about everybody right now, which is reproducible builds as well. But that's also coming. And then if you take a look at how you prove things, so those are the levels. Something else that we need to be looking at is, again, those proofs, because when those regulators come, or when somebody comes to look at a piece of open source and say, can I consume this? They want evidence. Evidence that the thing was signed, that it had multi-factor authentication on the repo, that it did run in a hermetically sealed build pipeline. And so those proofs are going to come and be recorded using, at this point, there's 2 emergent systems for recording proofs. One of them is just for recruiting, showing proof of signing. So if you're familiar with Let's Encrypt, this is like Let's Sign, basically, for open source software. This is a SIG store project, which is in the OpenSSF, which is ability to go and using ephemeral keys backed by OIDC identities, like your identity or the identity of your repo, get something signed that has no risk of leaking the signing key. And so it makes it very hard for an attacker to get that signing key and then go sign packages on your behalf. And second, proof that it was signed as well. That goes to a transparent, basically an immutable ledger that shows this package was signed by this key at this time, by this individual. So this is this project. So this is this transparency key log there. You can see these are all open source projects for each piece of this stack that you can go deploy, and you can now integrate it with PyPy, integrate it with GitHub. You can go get things signed with SigStore. So it's one of the very easy ways to just get some basic evidence of your provenance of your build pipelines. What Microsoft has been working on with the IETF and other companies is looking at it from an enterprise perspective and the things that we need to believe we need to have evidence of. Not just that something was signed on a particular date, but we're going to need connections with things and policies that are also recorded. Like, for example, the fact that I did a malware scan of a piece of software. That's a piece of evidence that we might need to want recorded and attached to a software bill of materials, which also is attached to evidence that it came from an attested build pipeline or hermetically sealed build pipeline or reproducible build. And there are a number of policies. We kind of have an idea of what policies make sense now. There's likely going to be more and more policies over time that we're going to need to provide evidence for in this immutable ledger so that an auditor can come and look and so that we can produce evidence, not just us, but of course anybody producing software. And this isn't just for open source software. This is also what we're already started using this internally, a version of this internally at Microsoft, for signing and recording attestations of some of our closed source software, including Windows. So this is actually, and this is an important note I also want to highlight. If you take a look at everything I've been talking about, it applies equally to closed as open. In fact, I don't look at it as open source software standards. I look at it as software standards. Like, what's the difference? We need the same controls. We need the same security for both types of systems. And so that's the way you should look at it. Whether you're open or closed, these systems apply, and these standards apply. Now, here's another example of a way to measure and determine if you're following best practices. And this one was also contributed by Microsoft. This one is aimed at how do I consume software? What are the best practices? And this one, if you have to actually sit down and think about it, all the things that matter. And once you start to think about it, it comes into picture, the things that you'd want to be secure from an open source consumption perspective. So from Microsoft perspective, as we sat down to say, how can we be secure? Well, you want to make sure that you've got an inventory. What open source do I have running? What versions of it is running? What am I pulling? So this is, the kind of engineering systems and having that visibility. When there's an XY utils or a log4j, how exposed are we? That you require an inventory for that. You want, even ahead of that, starting with ingestion, what can our developers ingest? Is it okay for them to ingest that package that has one maintainer, that with no MFA and no PRs on their contributions to the project? Is that okay? Well, we got to decide what are our policies. So that's something else, deciding the policies. How do you update? When there's a log4j, what are your processes to go and get the whole organization mobilized and get that patch in place and deployed quickly and safely? How do you enforce? Again, that goes to the ingestion policies. It goes to the deployment policies as well. How do you audit so that you can understand what's happened and what you've got? How you scan your systems, because it's not like static open source. Today might be secure. Tomorrow it's the exact same code is insecure because somebody discovered something about it. So how are you scanning and looking for new problems as they're emerging? And then one of them is, for something really critical, can you wait on upstream? This is something you got to think very carefully about. If there's a vulnerability in an open source package and your customer base is at risk of being harmed, or your own company's at risk of being harmed, and the upstream maintainer happens to be on vacation, what do you tell the world? Well, the guy's on vacation or girl's on vacation. Sorry, you're not getting a patch till next week when they're back. No. we're responsible. Our customers don't care. They look at us as we're supplying a service. We're responsible for that service, whether it's closed source, open source. And so if there's a vulnerability, Microsoft, keep us safe. So that might mean building temporarily yourself and releasing a patch while you're waiting for upstream on those critical projects that are high-risk surface areas at least. So that's another consideration here. So that is a look at consuming. Now, let's talk about measuring, actually, and some standards. So there's kind of standards, how you look at things, different levels of assurance. But let's take a look at how you actually measure how good you are. And one of the programs the OpenSSF has had for several years now is this scorecard, which is just a very lightweight measurement tool that you can point at any repo and get an idea for, and which includes CI/CD in some cases, get an idea for how secure it is. So it's got a bunch of measurements it does, and it'll produce a report for you in an automated way. Source risk assessment, build risk assessment, you get the idea, and each one's rated on a scale of 1 to 10, where 10 is you're doing awesome, just to show you how easy it is. And if you've got an open source repo, you should just go run this right now. Here's the tool scorecard running against the React repo that Facebook manages. And this is kind of sped up a little, 32 seconds, so sped up just a little bit. But you can see it's found some potential issues. It's hard to see, but just wanted to give you a flavor for just, there's no excuse not to go run this and see what it says and say, whoop, I didn't know about that. That's something I should go fix. And then the Open Source Security Foundation is also now establishing set of controls, common controls. Everybody working in software assurance and software regulation knows about controls. This is how you say, I want the build pipeline to be tamper-proof. Well, that's a control. Now, how you implement that control, that's a different question. It depends on the build pipeline and the mechanisms it's got for enforcing protection of the build pipeline. But the control itself is what people care about. The control, evidence that the control is met. So one of the things OpenSSF has started to do is define a set of controls that hopefully the world can start to align on for open source, including, ideally, regulators that are asking for open source compliance with their standards. To be able to say, you know what, we've got this control, we want you to implement it, and that can be mapped onto an OpenSSF baseline control. These baseline controls right now, it's kind of just getting started. There's about 40 controls, and they've got different levels of assurance for some of those controls. And you can kind of have these basic levels defined to go look at a project and say, how secure is it? So like 20 controls apply to the universal floor. Everything should do these things. And then you can see they build on one another. You want to go to level 2, you need to have those 20. Some of them might be more stringent too. So 18 total new controls come into effect, or new variations on those controls come into effect, and then level 3. And it's not just kind of these basic levels, but also OpenSSF has mapped these things onto open standards, regulatory standards like NIST, the CRA, DORA, which is forthcoming, to say, here's how these things map onto these regulated controls that are going to be coming at you. So this is to try to make it easy for us to just have a common language across open source for defining these things. And if you take a look at it, all of it is like, the more we can standardize, the more we can interoperate, the more we can share and build on top of one another. And then finally, the execution side of Open Source Security Foundation is a sub-foundation called Alpha Omega. And Alpha Omega came from us talking with, us meaning Microsoft, talking with Google, talking with Amazon, and saying, OpenSSF is great for education, defining these standards, supporting the tool development, but let's go and try to accelerate progress. So when there's an open source project that is, funded only to keep the lights on, can we go inject expertise and resources to get them to accelerate progress on open source? Of course, this needs a project that is willing, that has the time to go and engage like this, but we've found many projects, almost all projects, that are approached by Alpha Omega to say, hey, you're a critical project, would you like some us to help you accelerate your open source maturity, that they're all enthusiastically supportive. And so the alpha part is go high value, targeted, critical, deep engagements. The scale is let's go fun stuff that's going to lift all the boats. Primarily up to this point, the focus has been on alpha. And Microsoft, you see Microsoft, Google, and Amazon have funded $5.8 million into 14 critical open source projects to improve their security, including the Rust Trusted Publishing launch and CV authority designation, Apache Trusted Release Pipeline. So you can see a bunch of projects just in the last year where Alpha Omega has gone and helped execute and move things forward. So, want to just summarize here. I've given you a whirlwind tour. First of all, the world depends on open source. Microsoft heavily depends on open source. Open source is becoming more critical, and it's a high-value target for the threat actors out there. The risks are rising. We all need to move together. So, one takeaway that I'd love coming out of this, besides just going and running the scorecard just to see what it shows on the repos that you're involved with, is looking at this and taking some action. If you maintain open source, get onboarded to SigStore. It's really easy to go sign your packages. If you're building on open source, go to look at S2C2F and try to figure out what level of risk you're willing to tolerate versus the expense of doing some of those things in there. And then if your business depends on it, please support the OpenSSF and support maintainers. There's a lot of different ways you can support maintainers, including through GitHub. So that's the big takeaway. Now, I want to leave you with one last thing, which is just to, I know that Scale is famously a builder community that loves to get together and hack on stuff, including IoT devices. Well, yesterday I was just preparing for this and thinking about the implications of AI and AI's ability to find vulnerabilities. I was curious because one of my first open source projects was this one, back in 1986. How many people ever programmed on the Apple II, just out of curiosity? So quite a few of you. This is in high school. I wrote this tool. I reverse engineered AppleSoft, which now I don't need to do given the source code is public. But I reverse engineered it, and one of the limitations it had is you couldn't go to or go sub to a function. You had to go to a constant. So you'd say go to 10 to go to line 10. You couldn't say go to a plus 10, which might be nice if you had a sequence of different snippets of code depending on some choice the user made or some other condition. You'd go jump into the right piece of code just automatically without having to go if a equals 1, go to 10. If a equals 2, go to 30. You get the idea. So I reverse engineered AppleSoft, and I extended it so you could actually do computed go-tos and go-subs. And here's the source. Back then, you had to type this in. So last night I'm like, I wonder how Opus 4.6 would do on this, given the stories coming out about open source finding vulnerabilities in C++ and open source projects. So I went into GitHub Copilot and I told Opus 4.6, first I just go find the article online, download the binary that the user has to type in. These are truly the prompt. Download the binary the user has to type in, save it to a file, disassemble it, and then scan it for security vulnerabilities. Well, 10 minutes later, here's the disassembly. And it's brings back fond memories because it uses the same commenting that I used in my original assembler. This is basically it. So it fully disassembled it, understood exactly how this thing worked, and then did its security analysis and came up with this. I told it to make a markdown file. Came up with this, and you can see that it found some I'm kind of embarrassed for my high school self, that it found some of these, including one that is particularly embarrassing. This one right here, which is it doesn't check that find line found the new line. So it calls this function to go do that a plus 10 or whatever and gets back a line number, but it doesn't actually check to see if that line number exists. So if it doesn't exist, this is in the do restore, it actually will put the read pointer into an undefined location, which could be off the end of the program, could point to some non-existent, some data that's not really data. In any case, it's here's your problem. And by the way, it even suggests the fix. So in 10 minutes, I'm looking at 40-year-old machine language. It's reverse engineered it and found security problems with it. My mind was blown. I mean, I kind of expected it, but seeing it right in front of you, taking that binary listing from the magazine and getting to this in 10 minutes. So yeah, it's time to strap in because it's going to be some interesting times ahead of us. And with that, I want to just wrap up and just, hope you found this interesting. Hope you realize that Microsoft's come a long way from the early days that we don't talk about, and that you've got some good idea about just how critically the corporate world is taking security of open source software and how we want to help improve the security of open source software, but not hurt what has made open source software so fantastically successful for everybody and so much fun. So with that, thanks again for inviting me. This is another milestone of my open source journey. Have a great scale.
Thank you, Mark, for joining us. If you've got time, I'd love to do a couple questions.
Sure.
Normally, it is our tradition to hand you a Scale jersey now that you're part of the Scale family and team. Unfortunately, shipping couriers do not follow the some SLAs as some of the software that we do, but it is redirected to your office. Right, awesome. And I apologize for not having it here with you. Yeah. But we will have you donned in the team garb shortly.
Sweet.
But yeah, I've got somebody in the audience with a mic, I think. Okay. You want to grab one from the back, and then I'll get started. Sure.
Thanks. Nice presentation. Fanboy here. I've been using all your products for forever. A couple of points about your presentation. The software bomb thing and providing all the CVs that your product has, does it make it more easier for the AI industry to find vulnerabilities of your product? And then when you constantly get these vulnerabilities, how do you, as a company, keep patching the systems all the time? So is there a philosophical way of keeping some critical repos as less open source than more? Because, from that point.
Yeah, I think the question's, about this always in security, the security through obscurity or obfuscation versus the transparency. And I think that the fact is that slider on things is moving, and it has to move because you think that it's not disclosed. You think that it's not visible. In fact, but the fact is somebody's going and doing automated scanning now and automated attacks against repos and open source, and they're going to find it. So, and I'm not sure exactly, how this is going to play out because, of course, we don't want to, if we discover something ourselves, a company finds something, we don't want to put the whole world at risk by saying, oh, by the way, here's a vulnerability, this is the whole responsible disclosure thing, and keeping CVEs guarded for some period of time. And I think that that's not going to go away, but I think the timelines and the urgency we have to act on for critical vulnerabilities and critical components is going to be changing in the next year. Because somebody finds something like this and we're not aware of it, we know that somebody else is going to find it pretty quickly with AI, and we better go get our systems patched. And so going to your second part of your question, which is, how do we have to think about this? We have to get our patching systems up to, they've been designed for human rates of vulnerability discovery and exploitation. We've got to upgrade them to being ready, AI rates of vulnerability discovery and exploitation, and volumes too. So this is a big wake-up call, I think, for everybody, including Microsoft.
You just showed us that we don't even need the source code. You just need the
That's
binary,
right.
and AI will do it for you. So
Yep.
I don't know if open source. We've got one more question over here.
Hi. First of all, great talk. I like that Microsoft took us seriously now.
We have for a while.
Yeah, I know. Just had to say it. I saw this. I have been concerned for years for SBOMs and all this supply chain stuff. I like the initiative, but it looks like nobody uses Linux in the board or something because they don't talk about Linux distributions. And there's a lot of learning for the past 30 years on maintaining software supply chains and integrating software and make it live different libraries with each other and pipelines and all these build systems that we have. So what will be the role of Linux distributions in this initiative? Because I see it concerns me that they are not even mentioned.
Yeah.
And a lot of stuff that the good practices and all that stuff that you mentioned here, they are already being done in like Debian, Fedora, Arch, and a lot of Linux distributions.
Well, I didn't mention them specifically because I think they're not noteworthy, other than the impact and scale and actually sophistication they're at. They're not noteworthy when it comes to what they need to do. And SBOMs, they're all required to produce SBOMs. So just like Microsoft's required to produce SBOMs for Windows, all the distros have to produce SBOMs. If they want to be used by the U.S. government and more, the EU and other countries and organizations that are now requiring that as part of their, consumption policies. So yeah, if you haven't seen SBOMs, that's because they're not yet being required to produce them because they're not selling to those kinds of organizations yet.
Question over here.
Just one last one in the back.
Hey, so it seems we should get started doing SBOMs in our CI/CD. Maybe if you have some tools, I saw Anchor Sift seemed like a good way. And another thing is, can you detail a bit the roles of universities?
Yeah, so first, there are a few SBOM tools out there that you can put right into your build pipelines. In fact, Microsoft has a tool called SBOM tool that we open source that you can go use. That's the one we're using internally as well. So, yeah, no reason to just start to go produce SBOMs right now. As far as the role of universities, obviously educating students about open source security. Security has typically been you're interested in security, go this track. You're interested in software engineering, goes this track. Two separate tracks when actually it needs to be integrated now. You can't be a software engineer, computer scientist, or developer without also understanding security. So I think the role of universities and schools is getting security right there up front.
I think I imagine Mark will be happy to hang out for a moment and answer a few more questions one-on-one, but we've got another session starting in this room in a little bit. So want to go ahead and I think we'll want to call it here on the Q&A. But thank you again, Mark, for joining us. And thank you to Microsoft and GitHub for your support, and Tailscale and everybody else. Please stop by the expo hall, say thank you to our sponsors. Remember, we'll be back here this afternoon for a keynote with Professor Comer to learn a little about all the network underpinnings that helped build the world we live on today. So.